Let's now look at some exam questions regarding integration. The first one is this one. This is a paper 2 from June 2006, this question 7. The first part asked you just to differentiate natural logarithm of 2x plus 3. So this is a simple. Differentiate what you have inside, which is just 2, and multiply by 1 over that. So the answer is here. It's automatic. It's one-step answer. And you will have, it will be 2 points just for that. Hence, or otherwise, show that the integral between -1 and 3 of this equals natural logarithm of 3. Now that you integrated this and you got this result, all right, you can use this to do the opposite and try to prove that. Okay, well, what do I mean with this? Just write what you have, all right, and you know that this is going to be 1/2 the integral between -2 and 3 of 2 over 2x plus 3, all right? These two are the same. So now you can integrate this, because this is the same as that. And you know that if you integrate this, you have back the expression that you had to begin with, the natural logarithm of 2x plus 3, right? Now substitute 3 and -1 inside. You have natural logarithm of 9 minus natural logarithm of 1. This is 0, right? And 9 is what? 9 is 3 squared. So you can write the natural logarithm of 3 squared as 2 natural logarithm of 3. All right? The 2 cuts out with that 2, so that's just natural logarithm of 3. You had another question, which was this. Find the quotient and the remainder when 4x squared plus 8x is divided by 2x plus 3. The quotient and the remainder. All right? This you learn in the very first chapter of Pure Math 3. Just divide. You already know the rules. And the quotient is going to be what you have here on top, and the remainder is what you have over here. So that will be it. Hence, with this information that you got in the previous question, hence show that this integral over here equals 12 minus 3 natural logarithm of 3. If you pay attention to this, this is what you have and what you already calculated in on top. And you already know that if you have the dividend, the divisor, the quotient, and the remainder, they all link together by this expression over here. The dividend equals the divisor times the quotient plus the remainder. What you have over here, you have the dividend divided by the divisor. So just go ahead and let's divide this equation on both sides by the divider, right? And what you get? You get this. The dividend divided by the divisor equals the quotient plus the remainder divided by the divisor, right? Substituting with the values in question over here, the expression that you start with is going to be equal to the quotient, 2x plus 1, plus the remainder, which is -3. So -3 divided by the divisor, which is 2x plus 3. So instead of integrating this stuff, we integrate that, right? We can divide, or separate, I mean. And this one, we integrated, and this is going to be obviously x squared plus x between -1 and 3. And this over here, we already know the value. We calculated in the previous chapter. In the previous question, it was natural logarithm of 3 times the -3 that you have over here. All right? Then apply the minus through the boundaries over here to this expression, and here you have it, the result that you wanted. 12 minus 3 natural logarithm of 3. Next question is this one. It's in November 2005, paper 2, and it's question 6. A curve is such that dy by dx equals e to the power of 2x minus 2e to the power of minus x. The point 0, 1 lies on the curve. First, find the equation of the curve. Okay, so you are given the derivative. You are asked for the curve itself. So basically, you have to integrate what you have there, right? Integrating this should be easy. Just separate it into two different integrals, all right? then just apply the rules that you learned before, and this is just going to be e to the power of 2x over 2, and this is going to be minus 2 times e to the power minus x over minus 1, and this is the result that you'll have. You have to put the arbitrary constant, but you can use now this point over here to figure out what that is, all right? So when y is going to be equal to 1 when x equals 0, substitute x by 0, and you'll learn that c equals minus 3/2. So the final result is going to be this one over here. You should by now. Whoops. Just underline like I usually do the final result. For some reason, is not writing. I have to do it later. Okay. Then the next question is, the curve has one stationary point. Find the x-coordinate of this point and determine whether it is a maximum or a minimum point. So if it has a stationary point, you know that dy by dx equals 0 will allow you to figure out what that point is. That's what I did. So equal the expression, the original expression, to 0. Okay. I just put this e to the power minus x as 1 over e to the power of x multiplied by minus 2. All right. Found the same denominator over here. So multiply e to the power of 2x by e to the power of x. That's going to be e to the power of 3x equal to 0. This equals to 0 only if the numerator is 0. And then solving this will allow you to get the expression x equals natural logarithm of 2 over 3, which is more or less 0.231. And I did this because in order to figure out if this value is a maximum or a minimum, you could differentiate it again, but what I did was I substituted x by 2 points that are a little bit behind and above this value over here to see if the gradient is positive or negative. So a little bit to the left of the point, so 0.230, you're going to have a negative gradient, so the function is going down, and a little bit after that value, the function is going to be positive. So this is going to be a minimum.